Hello everyone! Hope you're all having a fantastic day so far. Nice little day on here in Killeen, Texas. Beautiful weather outside. It's a balmy 82 right now. Fantastic weather. Perfect weather for trig functions. And everybody's three favorite words with a calculator. Ah! You get to use a calculator. Finally. Finally. So, a couple of things here. Angle conversions using a calculator. You want to convert from degrees to radians. I don't know why that's the way I talk now, but let's convert from degrees to radians. 155 degrees. You want to convert it to radians. 155 times pi over 180. And look, I have my handy dandy calculator here. Got a calculator here. Times pi over 180 here. 2.705. 3 decimal places unless I tell you otherwise. It says so right here. 2.705 rads. Now notice when I'm using a calculator, I'm not really caring about keeping that pi symbol there. So times pi over 180. Magic happens with the calculator, and you get negative 1.257. So you're not really concerned about leaving it in terms of pi, and that's okay because we're rounding for decimal places. So anytime you see round to 3 decimal places, round to the nearest decimal place, whatever it is, then use your calculator, just punch it out. So convert from radians to degrees. Now this 5.8 times 180 over pi, if you calculate it, right, you end up getting 5.8 times 180 divided by pi, 332.315, and it says round to the nearest degree, so I'm going to call that 332 degrees. 0.324 times 180 over pi. And magic happens and we get 19 degrees. Rounded, of course. So down here, a couple of things about the circle at the bottom here. It says complete the table below. Label the approximate location of each angle on the circle to the right. Then label the approximate decimal value of the quadrantal angles in radians. What? Okay, so here's what they're saying. It goes from 0, it goes to pi over 2, it goes to pi, it goes to 3 pi over 2, and then it goes to 2 pi. Now what they're saying here is to label these in terms of decimal value. Well, half of pi is going to be about 1.571. Okay. Pi is about 3.14. 3 pi over 2 is about 4.712, and 2 pi is 6.283. Now, if you really think about this, think about the number values here. We said that your radians was something like 57 degrees, roughly, gave you 1 radian. So 2 radians would be double that. Now, since it's not exact here, here's 2 radians. Since it's not exact, if you were to actually double that, you'd actually get 115 because of the decimal value. Because it's 57.3. Remember that, it's 57.3 times 2. So rounding up. So then you have 3 right here. So that's going to be right about 172 degrees. Then you've got 180 degrees at 3.14. Then at 4, it's a little wide, but yeah, let me bring this back a little bit. Say here at 4 radians, we have approximately 229 degrees. Again, that's 57.3 times 4, rounding up. At 5, you got your 5 down here. 5 radians is roughly 286. And then 6 radians right here is 344 degrees. And that's just taking 57.3 degrees and multiplying by each of those numbers and rounding up. So it says determine the quadrant for each of the angles in radians. Where is 5 radians at? Well, 5 radians is in quadrant 4. What about 0.487 radians? Here's 0, here's 1, so 0.487 is going to be in quadrant 1. What about 2.5? Well, here's 2, here's 0.5, so that's going to be quadrant 2. Negative 3.5. Well, here was 3, here's 3.5, right? Now, if we go the same direction, or if the same distance but the other direction, we'd go right about 3 and then up to about 3.5, so that'd be quadrant 2. So just a little bit about some decimal values on radians. Nothing really crazy going on there just yet. If you go to the next page, notice I printed these a little bit bigger for you guys this time. You're welcome. I need you to be able to see your notes, right? Stupendous. B says finding values of trig functions using the calculator. Important note, always put your calculator in the correct mode before finding any trig values in your calculator. Mode. What the heck's it talking about, a mode? Number 9 here, for example. You're in degrees, right? We call these degrees. That's degrees mode. 11 and 12 are in radians, so we call that the radians mode. Because you got to tell your calculator if it in degree or if it in radian. So, sorry, I'm feeling goofy today. Sine of 30 degrees. First off, I need to go to mode. Let me click it right here on mode. Scroll down to where it said degree. Press enter and highlight degree. And then you can press sine of 30 degrees. Now you already know from the unit circle that the sine of 30 degrees should be 1/2. Well, fantastic. There it is. 0.5. How about the cosine of 47.2? Magic happens in the calculator. You'll get 0.679 as a value. Alright, so we're finding the values of trig functions here. Now I'm going to go to mode, and I'm going to click on radian, quick, and I do tangent of -5 pi divided by 8, right like that. Oh, I messed up. There we go. Oh, it's the same thing. Never mind. Sorry. It's that kind of a day. Anyway, type in your -5 pi over 8. It's 2.414. 2.414. Cosine of pi over 11. And it's 0.959. Okay, so the tangent of 3 pi over 2 without a calculator, 3 pi over 2 was down here at the point 0, -1. Tangent is y over x, which is undefined. What about with a calculator? Oh, I just wrote that in the wrong place. Undefined. What about with a calculator? If you were to type in the tangent of 3 pi over 2, what would actually happen? Let's try it. 3 pi over 2. Domain error? What magic is this? A domain error? Could that mean that it is also undefined? Be careful with those. If you get an undefined value for your, if you get an undefined value with the calculator, you have to go back and check it by hand. And what I'd like you to do is write yourself a little note here to remind you of that. If you get undefined on a calc, go back and check by hand. If you get undefined on a calculator, go back and check it by hand. So let's talk reciprocals. Well, the secant of 24 degrees, we said that's the reciprocal of cosine, right? So wouldn't this be 1 over the cosine of 24 degrees? Wonder if we could do that with a calculator. Mode degree. How about 1 divided by the cosine of 24 degrees? How about a little 1.095 if we round up? About the cotangent of negative 206.7. Cotangent is 1 over tangent of negative 206.7. So I'm going to do 1 over tangent of negative 206.7, negative 1.988. Yay! Cosecant of pi over 12 is 1 over the sine of pi over 12. So I'm going to grab my calculator, I'm going to put that thing in radian mode. Radian. And I do 1 divided by the sine of pi over 12. 3.864 if we round up. Pause it if you haven't, if you're falling behind. Pause it, go back, redo, blah, blah, blah. How about cotangent of pi over 2? And wouldn't that be 1 over the tangent of pi over 2? Now, for a moment, let's do it with the calculator and see what happens. How about we do 1, oh, wait, mode. Oh, it's in radian. Okay. 1 over the tangent of pi over 2. And it says undefined. Technically it says error domain, but we know that that means undefined. With a calculator. But without a calculator, where's pi over 2? It's up here at 0, 1. What's the definition of cotangent? What's the ratio of cotangent? Cotangent is x over y, which is 0 over 1, which is 0. Big difference between 0 and undefined. See, on 17, your calculator saw the tangent of pi over 2 and just said, it's undefined. But that's not necessarily true, because the cotangent of pi over 2 is defined. It's 0. That's why I say if you have to, if you get an undefined with a calculator, especially on quadrantals, really that should be the only time it ever happens, because that's the only ever time you have zero. So on quadrantals, if you get undefined, you better double check that, hombre. You better check. All right, one last thing here. We're going to do some simple algebra to trig. Some simple algebra. Solving simple trig equations, non-calculated. That means this a dude, it going away. I'm going to put him over here, and he ain't never going to see no light of day no more. Solving simple trig equations, non-calculator. Find all angles theta that satisfy the equations 0 to 360 and 0 to 2 pi. List your results in radians and degrees. Do not use a calculator. Ooh, this is interesting. So I've got some steps here on the side. It says ignore the sign of the answer and find the reference angle alpha such that sine of alpha is 3 over 2. So for a moment, I'm going to ignore the fact that this is negative, and I'm just going to say, where is sine 3 pi over 2? So looking at your reference angle, your alpha here is 60 degrees, or pi over 3. That's if you want to do it in radians, right? If you want to do it in radians. So you've got my sine values. See, I had a unit